For the that are on today, please don't worry, you will not show up on the recording. Your cameras will be off, so you will not, your faces will not be on the recording. So just to start, just a little bit of numbers on Northeastern. We're a top-ranked R1 research and experiential learning university, which means that we have the highest level of both research and experiential learning. Some examples of this would be our #1 ranked co-op program, and we are also ranked #1 in internships. We also received 282 million external research awards, the entire university. Although we're talking about the College of Engineering today, the college, or the university rather, is very large. We have 10 schools and we have 50,000 students. And as you can see here, we have a wonderful global university system. Although pharmaceutical engineering is only offered in the Boston campus, this is just a great snapshot to see where some of your other student colleagues may be attending university. Next slide, please. So our COE mission is mostly here on the screen, just to give you an idea of what Northeastern is. So we are really trying to put out people as our product in a world where technology is becoming more important. The college really does focus on the people behind the technology. So as we say, a good engineer solves problems, a great engineer solves important problems, and a transformative engineer discovers and solves important problems. So we're really here trying to make sure that you're a transformative engineer. Next slide, please. So here is just where your student colleagues are. You see we have the 5 disciplinary departments and 1 multidisciplinary graduate education department. These all offer a slate of different programs. So some of these you might recognize from the undergraduate level, some of them you may not, but this just gives a good sense of who else is in the college with you. Next slide, please. So this is kind of broken down by numbers. So the enrollment in the college itself is 10,000. So if you remember back from the first slide, the entire university population is about 50,000. So COE does make up a very large portion of the total population of Northeastern. And you can see too that we have more graduate students in the college than we do undergraduates. And this is a little bit different than many of the other colleges at Northeastern. Although we're talking about an MS program today, we do have a number of different degrees such as BS and PhD. And you can see here we have a large portion of faculty, both at the full-time faculty and tenure track faculty. And then just some of the numbers at the bottom, we are ranked 38th as the best engineering graduate school, and our undergrad is also ranked 37. Next slide, please. So here's just a little bit more by the numbers. I won't go into every single program, but just where you can see where we're spread out across the network. And you can also see that COE has mostly MS degrees, although we do have our PhD programs as well at the graduate level. Next slide, please. So here's just a little bit more about our faculty. They are very accomplished, so you can rest assured that you are learning from the best and the brightest while you're in the classroom. Some of the numbers there, you can see we have 245 tenure and tenure track faculty, and you can see some of their accomplishments, including Young Investigator Awards, NSF Career Awards, and you can see where our faculty are parts of professional societies, and we have 3 NAE members. Next slide, please. And then additionally, COE does have a large foot in the research sector. The college alone has up to 118 million in external awards. And we also have 20 multidisciplinary research centers, and our research thrusts are health, sustainability, and security. You can definitely, if you are interested, feel free to look up our centers to get more information on the research. And then this is just our outstanding facilities. These are 2 of our newer buildings in the college. The first one there is our ISEC building, and our newest building that just opened is our EXP. These are the newest buildings on campus, and they're great. They host our departments, they host labs, and they're just great places to kind of chill out and study as well. You can see on the slide there. Next slide, please. And just briefly, here are 20 research centers and institutes. If you are interested in them, I recommend taking a screenshot of them and looking them up individually. Each one has contact information, a little synopsis about what they do, and they will list the projects and the faculty that are affiliated with those projects. Next slide, please. And now I will turn it over to Adam, and he will talk more about the department.
Well, good morning, everyone. So my name is Adam Eckenshire. As indicated on the slide, I'm a teaching professor here in the Department of Chemical Engineering, as well as our Associate Director of Master's Programs. Joining me today, we'll have shortly Professor Ben Woolston as well as Mallory Moffett, who is already on the call with us. Some real quick facts about the department. We are a very diverse department in terms of our faculty. We are a large and growing department in terms of our student body. So we are now at 100 PhD students and over 50 master students. And we had over 300 students complete a co-op just in the past year. And this really speaks to how many of our students do these co-op experiences. Okay, so we will be really excited to have you join us here in the city of Boston. So Boston is an incredible place to do learning and also research and work in industry and do co-ops, right? So it's a great hub, especially in the biotech and pharmaceutical area. So it's really a great place to do pharmaceutical engineering learning if that's what you're interested in. And we have a little video here on the university and our system in general.
Our approach to learning is very simple, very powerful, and very impactful. It's called experiential education. It helps you integrate the classroom experience and the world experience. You're not only thinking, you're doing, and you're bringing the two together.
Co-op got me to see the real world application of what it is that I'm learning.
You get the more structured class learning to really get the initial concepts in your head, but then you get a chance to go on co-op and actually getting your own hands-on opportunities to try them for yourself.
And that just getting to swap back and forth between that it's intoxicating, honestly. It allows you to hone all these different skills at the same time.
You're coupling their new theoretical knowledge from taking more classes with their increased lab experience, and it's really, really powerful.
I was able to learn the process of research, which was cool, much different than a lab experience. Although a lot of the stuff I learned in lab, I was able to take with me.
To now be able to know exactly what questions I need to ask, what research I need to do, and just hit the ground running.
They gain a level of confidence that they wouldn't have necessarily received had they not had that professional experience. They also gain this level of professionalism that I see gets translated back into the classroom.
I think I understand how to study better and how to learn better and how to apply what I'm learning into different applications that I think I might have had a disconnect with before.
I have a high hiring bar. The program and the results that we see in that time is we can't compare it to anything else.
My advice, go to the International Co-op office. They'll help you find one in Asia. We have many students doing co-ops in Asia.
So it was kind of interesting just to see the values in China that some of the patients had, their families had.
Being in Portugal really helped me develop my language skills.
Realizing that there's so much more out there in the world. I think Northeastern caters their program to allow each student to have a lot of flexibility.
You really make your own experiences.
That's a little bit about the Northeastern University experiential model. We also have a short video here, more specifically on our Department of Chemical Engineering, inside which is housed this Master's in Pharmaceutical Engineering program.
Chemical engineers can solve any of the world's challenges. Climate change, health, medicine.
How do you build a sustainable world? All these different things that our future as a planet depends on, everything can tie back into chemical engineering.
The master's program is really coursework or research where you get a little bit more in depth than you did as a bachelor's student. And then the doctorate is really all about research.
Research facilities here at Northeastern are great. We have world-class equipment and capabilities.
My research focuses more on examining the endothelial calyx in organ-specific cancer metastasis. It affects many people. Many people have died from it. And so obviously there's just a need to find a cure.
Batteries, they produce a lot of heat. And if we're going to put it into an electric vehicle, we have to get different ways of removing that heat efficiently. Otherwise, we're going to see them flare up. My research is how can we improve polymer materials? How can we make these battery packs safer? And how can we make them more cost effective?
We spend a lot of time thinking about what allows our students to be their best selves and to pursue their own dreams and their careers.
Northeastern has the experiential model.
You're in charge of your own project. You have your own timeline that you create and the goals that you want to do.
We're embedded in this ecosystem that is really looking at how do we advance technology for health, for energy, and for climate.
Boston is a biotech hub, so there's so many pharmaceutical companies, and I was thinking about future career opportunities when I decided Northeastern.
That idea of finding where you want to be is just experiencing something before you do it and commit to it is just a really exciting opportunity. And so we encourage our students to do co-ops.
And then they come back with new knowledge and they've learned things that I wouldn't even think to teach them.
My co-op is at Rogers Corporation. When you get back into the field, you know exactly what to do because you've seen that before. You have the thought process down, you know where to go.
What's so great about Northeastern is just so much collaborations between different departments.
This is the most supportive community I've ever been in. Academically, professionally, personally, there's always someone there to support you and they just want to see you succeed.
Okay, so you got to hear a little from our department chair there in the video, Becky Willetts, as well as some of our other faculty and students. And so now let's talk a little bit about this pharmaceutical engineering master's degree program itself. So we created this degree program just a couple of years ago in response to really a growing need for engineers who can work at this interface between pharmaceutical sciences and applications and product development and process engineering. And so this is a cross college and interdisciplinary master's degree program. So you get about half of your core programming from chemical engineering and about the other half from pharmaceutical sciences, with a lot of elective options across different programs at the university, which we'll go a little bit through here. Within this context, right, we're looking to prepare students to be able to work in the pharmaceutical and biotechnology industries and do a lot of different things. So this is going to be not just technical engineering skills, but also understanding quality assurance, intellectual property, regulatory compliance, all these pieces that go into actually producing and working with pharmaceutical materials out there. So the structure in general is 32 credits over 1.5 to 2 years. As full-time, you can take it part-time as well. And again, we've got the core, 18 credits of that is core courses, and it's split between the two departments, as well as having 6 of those credits be experiential components in the sense that you actually get in and do labs. It's not all just theory-based courses. This does mean it is an on-ground and not online program because we want you here and learning with us. And then there's a lot of elective courses as well, which we'll kind of look at a little bit in a minute, right? And of course, you can do co-ops or internships. Most of our current MS in pharmaceutical engineering students are doing co-ops, many of them right now. So with that, I will turn over the next few slides to Benjamin Woolston, who helped develop the coursework and teaches some of the courses.
All right, thanks, Adam. Good morning, everybody. It's nice to be here. So I'll spend a little bit of time just walking through some of the philosophy behind the courses that you would take as part of this program. Oh, sorry. Can we go one more slide? Perfect. Okay. So as Professor Eckensayer said, the core is really divided equally between chemical engineering and pharmaceutical sciences. So you can see there's a 2-semester track in chemical engineering, 7600 and 7601. These 2 courses are really designed to teach you all the core principles of what define what it is to be a chemical engineer. So kinetics, reactor design, material balances. But the way we're doing this is all the examples, every problem that you see in these courses will be from the context of biopharmaceutical production, right? So these few slides will give you a few examples, right? So when we talk about kinetics, we're not going to be talking about chemical reaction kinetics. We're going to talk about enzyme kinetics or how cells grow and divide in bioreactors. When we look at heat transfer, another key component of chemical engineering, We're going to look again at biological examples. So you'll learn how do we manage the heat produced by microbes growing in bioreactors to make sure they can still produce the proteins and other recombinant molecules that they're supposed to be doing. How do we make sure we sterilize the reactor to make sure only our bug is growing in there? Right? The same applies when we talk about other transport phenomena. So mass transfer, big part of chemical engineering. Where we're going to see a lot of this in these courses is how we get gases into the bioreactor. So the organisms you grow to produce protein need to breathe, they need oxygen. And it turns out that's one of the biggest challenges in designing bioreactors is how do you get enough air in for the microbes to do what they need to do. Fluid flow, another part of chemical engineering. We'll look at unit operations that I guarantee you never saw as an undergraduate in chemical engineering, if that's your background, things like continuous centrifugation. So the point of this is if you are a chemical engineer by background, right, you'll be seeing some content that looks familiar, right? These principles should be familiar, but the examples that you're seeing for those will be brand new in most cases, right? Because it really is a biotechnology focus. Likewise, if you're not coming from a chemical engineering background, that's totally fine. We're going to teach you all of these things. And so this course is really designed, it's a really interesting course because we have both chemical engineers and non-chemical engineers in the course together, all learning together. So it makes it for a really exciting kind of set of interactions. So let's go to the next slide, if you don't mind. Yeah, so just to reiterate a couple of things I just said, we designed this program to work well whether you have an engineering background or not, right? So these courses don't assume that you know how to do mass balances or energy balances. They do, however, require that you are pretty good at math. It is really difficult to do engineering if you can't do calculus, in particular differential equations. So what we found is the students that struggle in these courses are those that either don't have a differential equation background, or it was so long ago that they forgot about it. So this is something we look for in the admissions process. It's an important part. But as long as you have this requirement, you should be okay in these courses. Again, these are engineering courses, so we're really emphasizing quantitative analysis, right? The idea is not that you just know how these processes work, but that you can design them. You can solve problems associated with the processes, right? Now, what you'll see when we start looking at biological processes is that if we try to do everything analytically by hand with math, we're not going to be able to solve very interesting problems. And so a big part of what we do in this course is we will equip you with the computational skills to do a lot of this analysis in programming languages like Python. And the benefit of this is that there's a couple of things. One is it will allow us to look at real world biotechnology applications, right? We won't be constrained to kind of made up examples where the math works. We can actually look at real problems. The second thing is I guarantee you, whatever career you end up with after this, being able to use a computer to solve problems is going to be an incredibly helpful skill. So it's one of the reasons it's a sort of a core emphasis within these courses. It's not all theory. So we are really excited. We developed a brand new lab class over the summer where you'll actually take everything I just talked about in the last few slides and actually apply this. So the lab is set up so you can do both upstream, which is basically everything up to and including the fermenter to actually grow the cells. And so you will actually grow cells in big bioreactors in the lab. You'll do the analysis, you'll work with them, you'll learn aseptic technique, all those types of things that are super important if you take an upstream job. Then you'll also see the other side of this, which is after you've grown the cells in the reactor, how do I purify the molecule of interest, right? And so you'll actually work with, in our case, we're working with fluorescent proteins, which is a really nice visual example. You can see these great fluorescing red cell pellets, and you'll actually learn the theory and the practice of how to purify proteins. Again, really important skill that will set you up for a number of engineering positions out in industry later. After the core is done, you can then basically specialize in a variety of different areas. We want everyone to take some courses in the regulatory sciences. And the reason for this is because biotech is an incredibly heavily regulated arena. And to be successful in this industry, you need to understand those regulations. Those regulations impact how we design the processes, how we engineer the cells, how we grow them in reactors. So understanding that is really important in any team that you end up with at the end. It's important to be able to analyze the results you're getting in the lab. And so there's one of the other sets of electives that we require you to take is from this quality and statistics track. So maybe you're interested in how do you design experiments, right? So you could take the DOE class here. If you're more interested in statistics, you can go in that direction as well. But all of this is focused on the idea that, you know, in biotechnology, big data is becoming important. The ability to analyze data sets and do it well is really important, and you need to know how to do these things. Then it gets to the fun part where you can specialize in an area of pharmaceutical engineering that you find most exciting, right? And so you can see, I'm not going to go through all the courses listed here, but you can see they span a whole range of different topics, from drug delivery, if that's what you're interested in, to how do you design new drugs. If you really like the chemical engineering aspects of this and want to go deeper into those, you could take our transport phenomena course. So these 7 credits really allow you the flexibility to move the degree in the direction that you find most interesting. Yeah, so that's kind of an overview of the core courses. Just a few numbers, if you're thinking about this program and why it might be a good fit for you or what you could do afterwards. You know, these are just some numbers that sort of give you a sense of what's going on in the industry right now. So in the Massachusetts area, right, there's been a huge investment in this space in the last few years. Boston is really now, I think, one of the 2 major hubs of biopharma in the US. So this is great in terms of employment after the degree. It's also great in terms of co-op opportunities. A lot of our students go to co-op at these companies, some of which are very established and some of which are startup companies. So you really get a lot of flexibility if you're in this area to explore career options that could work for you. I guess we're moving on. So I think that's the end of what I wanted to say, and I pass it off now back to you, Adam.
Well, next we'll be hearing from Mallory Moffat to speak a little bit about our graduate community, as we call it, within our department, and how students sort of interface and work together.
Hi, good morning, everyone. So I have 2 roles as of right now. I'm serving as the department graduate ambassador to the College of Engineering. So I'll talk about that first. We're here to kind of support first-year students as they are moving to Boston and help connect them to resources on campus once you do get here. So we have an email that's listed here. You can also check out our website. The next slide has all the different platforms that we're on. Feel free to scan the QR code. We're on literally every single form of social media you can think of. So we have some good content. I handled our newsletters that they post on both the Instagram and the LinkedIn page. So if you're interested in what events are going on, not just in the department, but across the entire College of Engineering, we handle events just like this. So you'll probably be seeing a good bit of me if you choose to go to school here. So that's pretty much it for that. And then the other thing that I do currently, I'm the president of our student council. We just held elections, so we'll have a new council starting in January, which is really, really exciting. But we serve as kind of the go-between students and faculty. We put on social events like the ones you see here, as well as academic and professional development events where we're doing a writing session. Next semester, we are really excited about launching some like how to adult series. So how to fill out taxes and all that good stuff. That's pretty much it. So that's our e-board. They're really great. We can go to the next slide. That's fine. And then apart from being on student councils and other things like that, we have a ton of really great professional organizations. So APE, there's GWISE, there's also an African engineering, sorry, I'm spacing on their full name. But there's a lot of different ways that you can be involved, as well as getting involved on the College of Engineering level, which is the COE PhD Council. And then there are ways that you can also serve by being a writing fellow through the Com Lab. So there's a bunch of different opportunities to get involved here at Northeastern. And then in terms of career success, yeah, we really love co-op here. There's a bunch of opportunities to take time away from classes and apply them. So you can work with co-op coordinators. They will help you actually go and find co-ops. OGS is really great for our international students. And I've personally used the career design and employer engagement. There's like a whole Canvas page dedicated to it with a bunch of modules, teaching you how to network, teaching you how to interview. So there's a lot of really great resources out there for you.
So thank you everyone for listening so far. So make sure to connect with us. We'll have opportunity for question and answers coming up. But first, we're going to hear a little bit more about the next steps to pursue if you are looking to apply to the program and hoping to enroll.
Great, thanks, Adam. I think we can go to the next slide. Perfect. So we have resources for our international students. So you will definitely hear a lot from our Office of Global Services. OGS can help you with the visa process. They can also help you find on and off campus employment. And they also can support you if you are traveling to campus. So if you are an admitted student, you will be working primarily with them as you submit your I-20 and those sorts of documents. If you're a prospective student and you have not yet applied, there is still plenty of time to do so, particularly if you are applying for fall. If you are applying for spring, as long as you are a domestic student in the United States, we still have a little bit of time left for you to submit your application. But in the fall, for MS students, our priority deadline is coming up on December 1st, but we also have our final deadlines listed on the page as well. So if you, for whatever reason, miss the priority deadline, that's not an end all for you. You still have plenty of time to submit your application. But if you do want a faster decision and priority consideration, we do highly recommend that you apply by the December 1st deadline. Next slide, please. So our admissions requirements are on this page for attending today. If you have not yet already applied, please feel free to use our application fee waiver that you see on the screen. Just one note that this does not go on the payment page. It does go on our applicant information tab. So as you're going through the application and you come to questions that ask you if you have a fee waiver, please select yes, or else the box to put this in will not appear. You do need 2 letters of recommendation to apply. We highly recommend that these are 2 people who can speak to the way that you can succeed in the program. So typically those are faculty or previous supervisors. For the application itself, you only need unofficial transcripts. We won't be asking you for official documents unless you are admitted. You'll also need to submit a statement of purpose and resume. And if you are an international student, with a couple exceptions, you'll be required to submit your English language proficiency exam. And we do accept the IELTS, TOEFL, and Duolingo. This department is also GRE blind. So if you're taking, for whatever reason, you're taking the GRE for another university, please do not submit the GRE. It will not be taken into consideration for your application. Next slide, please. So here's just more directions on the fee waiver code. I would recommend, if you are planning on taking advantage of the fee waiver code, that you just take a screenshot of this page. Like I said, it goes on the application information tab, not the payment page. So you'll know you're at that page when you get a series of yes/no questions. So just select yes to the question asking if you have an application fee waiver, and then a box should appear to insert the code. If you need assistance, please ask prior to submitting your application, because once you submit the application, we can't waive your application fee or insert the code. So if you have any questions at all, please do not hesitate to reach out to COE Grad Admissions. We're happy to help you. Next slide, please. And then lastly, we encourage you to keep in touch with the admissions team. You can see our COE website there. You can also find the application on our website. We also have a very robust list of FAQs. We find that a lot of students have the same concerns over and over. So If you're feeling lost and you feel like you have a question, please do not worry. You can rest assured someone else has already had that question. So I would recommend that you look at our FAQs, but if there is, for whatever reason, you can't find your question there, or you just simply prefer to speak with a live person, please feel free to reach out to the graduate admissions office, and we're happy to help you. Our email address is there. Like Mallory said, you can also feel free to reach out to the student ambassadors, but please do not reach out to the student ambassadors with things like application questions, visa questions, anything administrative. Our ambassadors are more knowledgeable on what it is like to be a student at Northeastern than anybody in the admissions office, but at the end of the day, they are students as well. So please, if there is a question that is more specific to admissions, please do not email the ambassadors, simply reach out to graduate admissions. We're very happy to help you. Next slide, please. Yeah, and I think that is it. We do have a Q&A tab at the bottom of your screen. If you do have any questions, we do have a little bit of time left. While everybody's on the call today, please feel free to ask your questions. And if nobody has any questions, or if you can't think of them now, please feel free to reach out to graduate admissions. But if nobody has questions, I think, okay, I see one question.
I'll take that question on for PhD programs. So this webinar here is geared towards the master's program in pharmaceutical engineering. So we do not have a PhD program in pharmaceutical engineering. Within the Department of Chemical Engineering, we do have a PhD program in chemical engineering. And so that's the one that you would be looking to apply to. You could still work with our faculty and take some of the classes and do work in biotech and pharmaceutical fields, but it wouldn't be called a PhD in pharmaceutical engineering. So in terms of the next question related to if you're eligible to apply to the program, so the answer is anyone can apply, but what do we look for in admissions? Well, we want to make sure you're going to be successful. So we want to make sure you're prepared for that first semester on campus. Things that can help you be successful are having the necessary math preparation skills. So if you don't have calculus or differential equations experience, then you're going to want to make sure you have a plan to get that learning before you are going to be here. And when you apply, we want to see that on your transcript, or perhaps at least hear from you in your personal statement what your plan is to make sure that you're going to be ready for those classes. Because if you get here and you don't know what a differential equation is, then that first semester is not going to go very well. So that's important. The other things that are definitely helpful are if you have backgrounds in biochemistry and organic chemistry, which many of our applicants do have some background, and we do have courses that kind of help you get back up to speed on those aspects, but we don't really have an on-ramp course for the math right now. So yeah, next question is similar on the math. So what we look for is up through Calculus 2. So we don't require Calculus 3, which would be multivariate calculus for this Master's in Pharmaceutical Engineering program. But we do want to see differential equations. And again, on your transcript, and record is best. But otherwise, if you send me an email and let me know what your plan is, or include that plan on your personal statement, then we can still consider your application as it is, because there are a lot of great applicants that maybe just aren't ready on the math skills. And so we just have to make sure that you are charting out a pathway for success there.
Great, Thanks. Does anybody have any additional questions before we end the call today? All right. Well, if no one has any additional questions, I think we're all set to end the presentation. I want to say thank you to Adam, Mallory, and Ben for being here today and presenting to you all. And then for our prospective students, thank you for joining. And then I do see the question, is the fee waiver code only applicable to this program? It is not. It can be used for any application in the College of Engineering, but yes, you can definitely use it for this program. But yes, if we have no further questions, thank you again to all the presenters and for everyone for joining today. And we hope you have a wonderful rest of your day. Thank you all.
Thank you.
Thanks, everyone. Bye-bye.